Welcome to DWBIADDA channel. Please subscribe for latest training videos.
Yes, hello everyone and welcome back to another video in the series of Scikit Learn machine learning, and in this video we'll be touching around another few concepts related to a very important topic in machine learning, that is natural language processing, and inside that we have the bag of words. Now we saw in the previous video of the what bag of word does is for us, and it creates us the necessary count vectorizers which we can use for our corpus conversion from textual data to the vector data. So as you can see, we have a specific corpus here. We'll be applying the stop words, followed by, when we make them the vector, we can see the number or the vector values which has been given to them. Now this is one of the default ways through which you can get the values for the vector, but there is also one of the practice which we call as TF-IDF weights that gives us the value of the same using the word frequency of the given data. Now as we can think, if a word has occurred many times in a corpus, it does mean that it is representing a whole value. Okay, so what it does is, instead of just giving random numbers or the distribution to the corpus in your data, it gives the vector value according to the values of its frequencies. Okay, so we get the the inverse frequency, so that's why it's known as TD-IDF vector. We can find that in the scikit-learn feature extraction for textual data. We have the TD-IF vectorizers. Okay, so it simply means to convert a raw document to a matrix of TD-IF features. So let's see it in action. So here we have another TDF vectorization that we have called. We have our corpus, and then to this time we'll be converting it into a TD-IF vector as compared to a normal corpus. So as you can see, our vectorizer has put and having a unique value this time according to the frequencies of the repetition of the values. That is a small concept of TD-IF vectorizers. And there is one more step that one can use in machine learning or like with natural language processing. What happens is, now hashing is one of the small trick that one can apply, which saves a lot of amount of memory and data. As what happens is, when you convert a vector, first the value gets converted into a dictionary format and then storing it, and after that it gets converted into a vector. What happens with the problem with that is, if you have a very relative size of corpus data, your buffer overflow situation can happen, allowing it to not get stored for the appropriate amount, and that what's the problem that you might be facing. So instead of that, we use something known as a hashing vector, which actually just directly converts your the corpus into the vectors, so allowing the two-step process to become just one, and then when it directly gets converted, yes, you save a lot of memory. So we can have the hashing vector present inside scikit-learn's feature extraction in textual data as a hashing vector. So this is the corpus we have this time, a very small relative corpus, but the important concept is to have a specific strength in the code of just having, instead of two-step process, just one-step process. So we call the hashing vector, giving the number of features that we want to produce for the same is 6. Now when we run this, we get the binary values as our hashing function, and the what happens is, in the background, the two steps processes have actually become one, and we save a lot of time in that. So that is the continuation of the bag of words and a simple trick of hashing. And yes, I'll be looking forward to you in the next class.